Okay, this video is going to be on types of relationships. And there's 5 types of relationships you're going to have to be able to recognize by either looking at the equation or looking at a graph. So the first type is going to be a direct relationship, and they're the simplest type. They take the general form of y is proportional to x. So we should recognize that if x doubles, y is going to double. If x triples, y is going to triple. An example, if we look at the equation for kinetic energy that relates to kinetic energy, mass, and velocity, here's the equation over here. Okay, Ke equals 1/2 mv squared. Ke is just going to be proportional m because on that m there's no squared, no square root. Okay, and if m doubles, the Ke is going to double. And if I make a graph of it, I end up with a nice straight line. So a direct relationship, you get a straight line. The next one we're going to look at is an inverse relationship. They take the general form of a is proportional to 1/x. They're reciprocals. So if x doubles, y is going to be halved because I have 1/x here. And if x triples, y will be 1/3 as large, and so on. So if I look at the equation relating power, voltage, and resistance, power is equal to voltage squared divided by resistance. And if I look at just the resistance part and ignore the voltage, I get power is proportional to 1/r. So if the resistance here doubles, it's going to make the power half as big. And a graph of that looks like this. As the resistance goes up, the power goes down, but it's an asymptote. It never reaches 0. A quadratic has a general form of y is proportional to x squared. So if x doubles, x squared gets quadrupled, so y is quadrupled. And if x triples, I put a 3 in here for the x. 3 squared is 9, so y will be 9 times as big. Again, we're going to go back to that kinetic energy, mass, and velocity equation, but this time we're going to look at Ke and v and ignore the m and the 1/2. And I get Ke is proportional to v squared. So if the velocity quadruples, the kinetic energy becomes 4 squared times as big, or 16 times as large. And if we make a graph of that, you should kind of recognize something with this square in it is going to make a parabola and curve up this way. The next one is inverse squared. It takes a general form. Inverse is going to be 1/, but then the x is squared in this case. If x doubles, y becomes 1/4 as large because I stick a 2 in here for the x, and then I square it and I get 1/4. If x triples, y will be 1/9 as large. And that works for gravity. As the two masses get farther apart, the force gets weaker and weaker. So here's the equation. Fg is g m1 m2 divided by r squared. If I ignore all the other parts, except for the distance, the r, I get Fg is proportional to 1/r squared. So if r quadruples, Fg becomes 1/16 as large, because I put a 4 in here for the r, and I get 1/16. And a graph of that looks like this. Just from your naked eye, you can't tell the difference between it and a regular inverse. And then the last one we're going to talk about is the square root. General form is going to be y is proportional to the square root of x. If x doubles, y becomes square root of 2 times as large. If x increases by a factor of 9, y will be square root of 9, or 3 times as large. So the period of a pendulum and its length are related by a square root relationship. So here's the equation. The period of the pendulum is equal to 2 pi square root of L/g. I ignore everything except for the L, but the L is under the square root, so I end up with t is proportional to square root of L. If L quadruples, t becomes square root of 4, right, because I put 4 in here for L. T becomes a square root of 4 times as big, which is 2 times as big. And a graph of that curves this way. Now, this isn't all of the relationship you might run into. These are the most common ones and the ones I want you to have memorized. So when you are looking at the relationships, you need to know the 5 types: direct, inverse, quadratic, etc. Be able to identify them by looking at a graph or by looking at an equation. Be able to determine what happens to the dependent variable when the independent doubles or triples and so on. and be able to sketch a graph.